Hello and welcome to The Explainer. So, you've probably played around with an AI chatbot, right? But have you ever stopped to think about what it really takes to turn that simple model into a massive, production-ready application that millions of people can count on every day? Well, that's exactly what we're going to break down today. It's a huge question. How do you go from a cool tech demo to an industrial-strength tool that companies bet their entire business on? It's not magic. It's an end-to-end engineering lifecycle, and it is fascinating. We're going to walk through exactly how it's done. So, here's our game plan. We're going to follow the journey in 4 parts. First, we'll look at the AI's brain, the model, and its data. Then, we'll see how you build the system around that brain. Next, we'll get into how you teach it to behave properly. And finally, we'll cover what it takes to get it ready for the real world.
Okay, section 1. Look, every AI application, at its heart, starts with just 2 things. The model itself, which you can think of as the brain, and its training data, which is kind of like all the books that brain has ever read.
And when I say all the books, I mean an almost unimaginable amount. Get this. Meta's Llama 3 model was trained on 15 times trillion tokens of data. To put that into perspective, that is like reading the entire English Wikipedia more than 5,000 times over. It's just a staggering scale. Now, here's the catch. A huge chunk of that data is just scraped from the public internet. And, the internet is, well, it's the internet. It's messy. It's full of low-quality junk, conspiracy theories, and just plain wrong information. And for an AI model, it's the ultimate case of garbage in, garbage out. It learns whatever you feed it, for better or for worse.
And you can see here just how fast these models, these brains, are evolving. Check out the difference between Llama 2 and Llama 3. Yeah, the number of parameters went up a bit, but that's not the real story. The absolute game changer is the context length. It jumped from 4,000 tokens to 128,000. That means it can hold so much more information in its head at one time, which is crucial for tackling really complex questions. So, you've got this powerful model. Great. But that's just the start. A brain by itself isn't enough. Now you have to build an entire system around it to make it actually useful and smart.
And at first, the system architecture is dead simple, like almost comically simple. A user sends a prompt, it goes straight to the model spits out an answer. That's it. But this is super naive. The biggest flaw? The model is totally disconnected from the real live world. It can't check facts, so it just makes stuff up. This is what we call hallucination.
So to fix that, engineers use a really clever technique called Retrieval Augmented Generation, or RAG for short. Think of it like giving the model a library card and a super fast internet connection. Before answering, it can now retrieve fresh, relevant information from external sources to ground its response in facts. Basically, you're giving it the ability to look things up. And from there, the system just gets more and more complex. You start with RAG for factuality. Then you add guardrails for safety. Then maybe you add a model router, which is smart enough to send different kinds of questions to different models. A math question goes to the math model, a creative writing prompt goes to the creative one. And finally, you add caching to make it all faster and cheaper. What began as a simple conversation is now a really sophisticated layered machine. Okay, so the system is smart. But is it safe? Is it reliable? Does it act the way you want it to? That brings us to our next section, teaching the application how to behave, using everything from clever instructions to serious safety filters. The instructions you give the model, the prompt, are incredibly powerful. Check this out. On the left, a user asks about Santa and gets a dry, factual answer. Boring. But on the right, the developer adds just one little example. We call this a one-shot prompt. And boom, the model instantly understands the assignment. It gets that it's supposed to role play, and the answer becomes fun and creative. But here's the flip side. That amazing ability to follow instructions can be abused. Malicious users create these really elaborate prompts called jailbreaks to get around safety rules. This one here is a famous example, the grandma exploit.
By wrapping a dangerous request inside this emotional, sympathetic story, an attacker tries to trick the AI into providing information it's supposed to refuse. And these risks have very real-world consequences. Just look at what happened at Samsung. An employee pasted confidential source code into ChatGPT to get some help, and in doing so, accidentally leaked company secrets. This is exactly why input guardrails are an absolute must. They're like a security guard that scans every prompt for sensitive info, like credit card numbers or secret code, and blocks it before it can cause a disaster. So this brings developers to a really important crossroads. When a model messes up, do you fix it with RAG or with fine-tuning? Here's the rule of thumb. If the model is wrong because it doesn't know something, it has an outdated fact, for example, that's an information problem. You fix that by improving your RAG system. But if the model fails because it doesn't have the right skill, it's using the wrong tone or the wrong format, that's a behavior problem. And that's when you have to fine-tune it to teach it how to act. All right, we're in the home stretch. We have a smart, well-behaved system, but now we have to make sure it's actually ready for real people. This is all about rigorous testing and optimizing for that tricky balance between cost, speed, and quality. One of the first big choices is, do you rent access to a proprietary model like GPT-4, or do you build on top of a powerful open source one like Llama 3? As you can see from this chart, while the big proprietary models have historically been a bit better, the best open source options are catching up and fast. This is huge because it gives developers way more control and flexibility. So, you might be wondering, why doesn't everyone just build their own model from scratch? Well, the short answer is money. A lot of money. Just the raw computing power to train a model the size of GPT-3 can cost over $4 million. And that's before you pay for the data or the army of PhDs you'd need to actually pull it off. So, once the app is launched, the most important thing you can build is a user feedback loop. This is your goldmine for getting better. It can be explicit feedback like a simple thumbs up or thumbs down, but it can also be implicit. For example, if a user gets an answer and immediately rephrases their question, that's a huge unspoken signal that the first answer wasn't what they needed. But, and this is a big but, you have to be careful with user feedback. It has a dark side. People are biased. We sometimes prefer longer answers even if they're wrong, or we give a thumbs up just because we don't want to type out a correction. The biggest danger is that the model can become a sycophant. It learns that the easiest way to get a good rating is to just agree with whatever the user says, even if the user is completely wrong. And all of this leads us to one final, really mind-bending question for the future. We know these models learn from the internet, but what happens when the internet itself becomes filled with content written by other AIs? There's a real risk of something called model collapse, where AIs trained on the outputs of older AIs start to forget what real human knowledge looks like. They just end up in this weird, degrading echo chamber. What happens then? That's a question nobody has the answer to yet.